Hey, are you picking a data center, unsure of what you should be looking for, can't figure out what makes one data center provider better than another? Well, you came to the right place. Welcome back. In the last video, I talked about building your own data center versus leasing colo space. Spoiler, don't build your own. And we talked about the different tier levels and what they mean, and we talked about redundancy factors as well as some frequently used terms. So if you didn't see part one of this series, please check it out here. I'll wait. All right, I think I waited long enough. So let's talk about the facility itself. There are three key words here: location, location, location. That is the real estate mantra, and it's true with data centers as well. There's several ways in which location is really important. First, you may want a data center in a location near your IT resources and staff. Frequent trips to a remote location can be problematic and expensive for regular maintenance. And if you do need to do emergency work, having your data center quickly accessible may be critical for you. You should also consider the challenge of moving data. You may need a data center that is in close proximity to the source of your data generation. You should also consider how you manage DR and replication, and whether you need a low latency connection to reduce your RTOs and RPOs, or if you're running an active environment that needs low latency to maintain consistency. And perhaps one of the biggest factors these days is proximity to the cloud. If you are thinking of pursuing a hybrid cloud strategy, having a data center that has direct connect facilities to your cloud provider of choice is critical. And this can allow you to access the cloud through a simple cross connect rather than having to buy circuits and set up VPNs. Now, many data centers have connectivity to cloud providers through partner networks, but the direct connect facilities are your best bet if you're going to do anything latency sensitive. And there's not a lot of them, and for the most part, they tend to be more premium data center facilities. So some of that vetting work has already been done for you by the cloud providers. You should also consider the facility's proximity to utilities like electrical grids and natural gas service if they have biofuel generators, for example. Make sure these utilities have diverse paths and entrances to the buildings. Also, you should consider the proximity to telco carriers that are important to you. Make sure the facility you are moving into has access to circuits that are diverse to the building and access to regionally diverse paths. Here in Chicago, most telco runs through the NAP here, the network access point, and that's at 350 Cermak. But you can find circuits that bypass 350 Cermak to deliver divergent connectivity. Another thing you should consider is planning for a facility that allows you to avoid natural and man-made disasters. You should look for a building that is fully dedicated to being a data center, a single use. Being in a building with other businesses can introduce risks. You don't want your data center damaged by a kitchen fire or a flood from other businesses in the building that don't have the same standards as a data center. Check to see if the facility is on a floodplain. Check for seismic activity. Is it in an area prone to tornadoes? And if it is the facility hardened and protected from extreme weather? Be cautious about facilities near airports, train lines, or highways. A chemical spill from a truck on the highway could shut your facility down. Hazardous material from a derailed train could put you out of commission. Now, often businesses will have a requirement to maintain a certain distance from nuclear facilities or chemical plants. And there can also be a requirement for a certain minimum distance between facilities. So you need to factor all of these things in when looking for a facility. Take a look at what shape the building is in. Ask questions about the building itself. What does the roof look like? This may seem silly, but I can't begin to tell you how big a problem this is for so many data centers. If the roof leaks, you have major problems. And if it needs to be replaced, that is very disruptive construction. If the facility looks beat up and shabby, it probably is. And it probably has bigger problems that you can't see. So let's talk about construction. Building data centers is a very capital-intensive business. So they're often built in phases. And it's generally a good thing to have additional phases that will come online in the future, as that gives you the option to move to a new, more modern facility down the road. However, Construction can create problems. Be aware of what construction is ongoing and what is planned, and how will that be contained relative to your location. Construction can bring power outages, damage, fire, general inconvenience, and usually tons of dust, which is the enemy of computer gear. If managed and planned well, new construction can be safe and a sign of a healthy business, but make sure it won't impact you. I worked on a data center build at the 111 8th facility in New York, and they were rapidly developing the building, and it seemed like every day the path to get to the data center changed as walls went up and moved around. Some days I would have to go up a floor and then down a floor and then up again to get around construction or a new data center that suddenly appeared in my path to my facility. Another thing to vet thoroughly is a company's financials. As I said, this is a very capital-intensive business. Facilities can cost hundreds of millions of dollars. They are often heavily leveraged. Try to be sure the company is not over its skis. They will always paint a rosy picture of their finances, so see what the word on the street is about the facility. Check what people in the industry say about them. Now, much of it's going to be FUD, but sometimes where there's smoke, there's fire. Look for signs of a lack of investment in a facility or kludgy repairs. Good brokers can oftentimes help steer you away from failing businesses. Consider your needs. Do you just need a locked cabinet in a shared space? Do you need a SCIF, a secure compartmentalized information facility, or something in between? Do you need some workspace to have a desk and store tools? Do you have regulatory concerns like ITAR, where foreign nationals cannot be in the building? Or do you have to satisfy NIST SP 853 standards for government work? Will the facility you're looking at support these efforts? Let's talk about a couple interesting terms that you're probably going to hear regularly when looking for a facility. MEP and PUE. MEP is a term you'll hear being used in the industry. MEP stands for mechanical, electrical, plumbing. This covers electrical systems, cooling systems, air handling systems, etc. MEP is the lifeblood of the data center, and see what their capabilities are for maintaining these systems. They have electrical engineers on staff for both low and high voltage situations. Do they have HVAC engineers, etc.? Having engineers on staff to handle these systems is a positive sign that they're making the investment in the people to run the facility. Now, PUE is another term you will hear referenced quite frequently. PUE stands for Power Usage Effectiveness. This number is a ratio that describes how efficiently a facility uses power, how much power is used by the computing equipment versus how much is used by the facility cooling and overhead. The lower the number, the better the efficiency. Now, this number is not an exact science, and quite frankly, it is often just guessed at or completely made up. So take it with a grain of salt. But take a look around the facility and see if they are doing those things to make the facility operate more efficiently. On the power side, make sure the power systems will meet your needs. Understand what types of circuits you are going to need, 3-phase, 220, 110, etc. Ask if they support all the socket types you need. And here's a pro tip. If you're running all 220, make sure you put in a couple of 110 circuits for things that don't take 220, because you will invariably need some 110 circuits at some point. Find out how many kilowatts they can support in a cabinet if you have large power needs. Do you want power fed off a bus so that you can reconfigure things easily, or is it okay to have power coming off of whips, which are cables running back to a panel? Understand your options. Ask if they supply in-cabinet ATS units for systems that only have one power supply. You may need this if the facility does A/B power outage testing. Make sure there is sufficient power capacity to grow. And if the facility is running near capacity, see if the utility has capacity to provision more, and ask what the plans are for the facility to add more power. Ask about the full power path. There should be diverse entrances. From these entrances, the conduit paths should be completely divergent and not overlap at any point. You don't want a situation where there's construction and they knock out the conduit for both sides of power. One thing that people often ask about is whether the facility is receiving service from multiple power grids. For most facilities, this isn't practical, and I would argue it is generally unnecessary. The electrical infrastructure in this country is in pretty dodgy shape, and in many other countries, it's worse. If a grid goes down, there's often a high probability of a larger cascading failure. I don't put a whole lot of stake in the multiple grids thing. What is important is on-site generation capabilities. On-site generation is usually supplied by generators, and they're typically diesel. There are some biofuel generators that can run on diesel and natural gas, and there are even some fuel cells out there. Biofuel generators are really nice because they can greatly increase run times. The natural gas supply is a fully diverse source to the electrical grid, and since it is a pressurized system, it can keep going even when the power is out. The problem with biofuel generators is that they are typically smaller, in the 600 kilowatt range, and can't provide enough power for many facilities. When you're in the multi-megawatt range, diesel is king. Ask about their maintenance and testing procedures. Diesel generators need to be tested frequently. In cold weather, they need to be started on a regular basis so that you can be sure they will start when you need them to. In very cold winters, we used to run our generators every single day to make sure that they were going to work in an emergency situation. Burning fuel also helps with keeping the fuel free from fungus and mold. Diesel can be tricky to store over a long period of time, and you have to manage to these things. For diesel, you should also check what the on-site storage capacity is. How many hours of runtime do they have with the fuel on site? And this will change over time as the facility power consumption increases or decreases. So you should probably ask what it's engineered to deliver at max capacity. Ask about their supplier contracts. Do they have rolling stocks or fuel in trucks? Consider that life safety services are going to get the priority in a major catastrophe. So all those contracts might just go out the window. So having that storage on site is a really critical factor. I had a situation once where the region we had a facility in got hit by some tornadoes. Power was out for several days, and it was our practice to top off the fuel tanks a couple times a day just to make sure. And after getting topped off one day, the driver said to us that this was going to be his last delivery, which is not what you want to hear when the power is still out. And he explained that the power was out at the fuel storage depot, and they didn't have any backup generators to operate the pumps to fill the trucks. Now that is a failure mode that I hadn't previously considered. In the end, we had enough capacity to weather the storm, but I felt bad for those who had less capacity. So let's cover the rest of the power path. I knew a guy at a facility who could talk for hours about how they designed the grounding system, which is actually a really important thing for a facility that people don't really generally talk about. Now, there are TVSSs, transient voltage surge suppressors for the facility, ATS automatic transfer switches, which rapidly transfer power sources in an outage situation. And engineers are often very proud of the designs of these things and would love to talk to you about this stuff. So if you express an interest, you can probably have a good conversation about it. And if they're not proud of the design, it's good to know that as well. Check on the UPSs. In a data center, much of the infrastructure is depreciated over a 10 to 15 year period. So ask about the age of the equipment. Make sure that they are on a regular maintenance schedule. Ask when they had the batteries last replaced or the capacitors redone. This is all work that can be very disruptive, and sometimes you encounter UPSs that don't even have bypasses built in, so they have to take a hard outage for any maintenance on the system. Some facilities have more exotic things like flywheels or UPSs with lithium-ion batteries. The bottom line is having enough time to switch over to generator power. So ask about how long they can run on UPS before switching over to generator, because having a little bit of buffer is a good thing, because sometimes generators don't start and you need to have the time to go and get those generators started. Ask about maintenance contracts and who does the maintenance. Check that the electrical work is done correctly and that all of the cables are in conduits and that they're finished and dressed nicely. If they take the time to make it all look good, they probably did a good job of installing it in the first place. Check on the PDUs, not the ones in the cabinets, but the big power distribution units on the floor, and that the A and B sides are isolated from each other. It's also good to check around and see if the phasers are generally properly balanced, because this shows that they're taking more care in managing their power. But that's something that you're probably unlikely to get. Take a look and see, is all of this out on the floor or is it contained in a galley? So they can do maintenance without disrupting your equipment. See if they can show you their MEP rooms, because they can be really interesting. You can learn a lot from an MEP room. You might also want to inquire as to how green the power sources are, if that matters to your organization. Is it coming from coal, nuclear, wind, hydro, solar? Different markets offer different things, And different markets can have wildly different prices per kilowatt or subsidized services. One other thing that is rare to find, but is something you might want to consider, is EMP shielding. EMP is a very real problem. From high-altitude nuclear detonations to solar flares to gamma-ray bursts from exploding stars, all of these events can create EMP bursts. And depending on the nature of your business, you may want to take a good look at this. This is a very cool and complex topic that is way too much to go into here, but I did a video on EMP and EMP shielding facilities that you can check out over here. I don't want to run too long, so I will pick up cooling systems in the next video, followed by network, fire suppression and detection, security, monitoring, add-on services, and ultimately negotiating the contract. Please click like, subscribe, and hit that bell icon for updates. If there's anything you want me to cover, let me know in the comments, and I will see you in the next video.